I am Ajay and I'll be your pactor for arithmetic progressions. Arithmetic progression is considered to be a very natural topic as it directly relates to pattern recognition, outlining your ability to sense, identify, and possibly come to an observation by solving it. Big words, I know, but the pure truth. We'll be using the WaHPACT effect, that is, what, why, when, where, who, and how to complete our journey of arithmetic progressions and make you absorb the basic pattern of arithmetic progression. The objective is to develop your ability to not only identify arithmetic progressions but also to make you skillful with them. Let's start with some facts before we start with arithmetic progression. The assumption is that you have a good understanding about these facts. Familiar with numbers and basic operations. That's the first assumption. The second assumption is list of numbers. For example, 2, 4, 5, 7, 8 is a list of numbers. 1, 2, 3, 4, 5 till 100 is also a list of numbers. Abbreviation is shortened form of word or phrase. Do you remember the divisibility test of 7? I guess not. So let's take this as a refresher. If we have a number where we are checking it to be divisible by 7 or not, we take off the last digit of the number, double it and subtract the double from the remaining number, that is after removing the last digit. Let's take an example. Say we have a number 994 where we want to check whether it is divisible by 7 or not. 4 is the last digit, so double of 4 is equal to 8. So finally 99 minus 8 is equal to 91. We see that this number 91 is divisible by 7. So eventually 994 is divisible by 7. You should have an understanding about the solution of quadratic equations via splitting the middle term and other methods also. Perimeter of a circle is 2 pi r, where r is the radius of the circle. Let's start our journey of arithmetic progressions. There are many famous stories associated with arithmetic progressions. One that comes to mind directly related with arithmetic progression is a story about famous mathematician Carl Friedrich Gauss. The story goes like this. As a 9-year-old boy, Gauss's teacher wanted to punish him for goofing around and stated that he was so smart, why didn't he go and sit in the corner and add up all the integers from 1 to 100? Gauss, at such a small age, without picking the pencil, gave the answer in literally no time, as 5050. The teacher did not believe him and started adding everything, and to his astonishment, the answer was 5050. The logic was very simple. 1 plus 100 is equal to 101. 2 plus 99 is also equal to 101. 3 plus 98 is also equal to 101, and so on. The addition was actually 101 into 50 times, which is equal to 101 into 50. Thus the answer was 5050. So what is arithmetic progression? Progression comes from the word progress, and in mathematical terms, it represents a number of things in a series. Each number in the list is called a term. Arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Arithmetic progression is often abbreviated as AP, simply taking the first letters of arithmetic, that is A, and progression, that is P. So finally we have the abbreviated name of arithmetic progression as AP. The fixed number is called the common difference of arithmetic progression. So the next logical question is, what is common difference? The fixed number is called the common difference. The common difference can be positive, negative, or zero. It is important to remember that the common difference can be positive, negative, or 0, and that's the reason I'm again repeating it. Let's take a few lists of numbers: 3, 6, 9, 12, 15, and so on. Here we can see the common difference is positive 3. The next term after 15 will be 15 plus 3, which is equal to 18. Another list of numbers can be 100, 80, 60, 40, and so on. Here we can see the common difference is minus 20. The next term after 40 will be 20, that is 40 minus 20, and after this it will be 20 minus 20, which is equal to 0. Another list of numbers that can be taken is 4, 4, 4, 4, and so on. Here we can see the common difference is 0. The next term after 4 will again be 4, as the common difference is 0. I know this is sounding a bit obvious, but that is how we can apply common sense and identify what is a common difference. All the three lists of numbers given above show arithmetic progression. Now let's take another list of numbers: 1, 4, 9, 16, 25. In this, no common difference can be observed. This does not show arithmetic progression. Let's take another example: 5, 7, 9, 11, 13, and so on. This list of numbers is an arithmetic progression with a common difference of 2. Let's take another list of numbers: 1, 2, 3, 4, and so on. This is an arithmetic progression with a common difference of 1. I know we have taken a lot of examples, so finally I hope with the development of common difference, we have developed an understanding about arithmetic progression. So the next logical question is how to identify that the series or pattern is in arithmetic progression. Arithmetic progression is a sequence of numbers such that the difference between the consecutive terms is constant. Consecutive term is the second minus the first. Example: 1, 4, 7, 10, and 13. Here we see that the consecutive terms have a difference of 3. If even one number in the sequence does not follow this rule, the sequence of numbers is not in arithmetic progression. For example, 2, 6, 8, 10, 14. We see that this is not in arithmetic progression because the difference between 6 and 2 is 4, whereas the difference between 8 and 6 is 2. Also, the difference between 10 and 8 is also 2. But just to mention that by removing one number 8, the sequence 2, 6, 10, 14 then exhibits arithmetic progression. Let's understand how to identify arithmetic progression in a simpler way. Let's denote the first term by A1, second term by A2, and so on. The nth term can be expressed as An and the common difference by D. The arithmetic progression becomes A1, A2, A3 till An. So A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 and so on till An minus 1, which is equal to D, in order for a list of numbers to exhibit arithmetic progression. Some more real-life examples showcasing arithmetic progression are: say the total savings every month for 6 months when rupees 500 are saved each month are 500, 1000, 1500, 2000, 2500, and 3000. So another example can be: I have recently started jogging and plan to increase 500 meters every day for 5 days. So actually what I'm saying is I will be jogging 500 meters the first day, 1000 meters the second day, 1500 meters the third day, 2000 meters the fourth day, and 2500 meters the fifth day. A very curious question about arithmetic progressions can be: what are the types of arithmetic progression? A list of numbers as A plus D, A plus 2D, A plus 3D, and so on represents an arithmetic progression where A is the first term and D is the common difference. So there can be two types of arithmetic progressions. finite arithmetic progression, which is an arithmetic progression AP that has finite number of terms. In other words, there is a last term. The second categorization can be infinite arithmetic progression. An arithmetic progression AP that does not have finite terms, that is, eventually an infinite arithmetic progression does not have a last term. Let's solve some examples to check what we have learned. Are the following list of numbers in arithmetic progression? If yes, then what is the common difference and the next two terms? It is assumed that by now you know AP means arithmetic progression. So we see a list of numbers as 2, 7 by 2, 5, 13 by 2 and 8 and so on. So we see the difference, that is D, is equal to 7 by 2 minus 2, which is equal to 5 minus 7 by 2 also, which is equal to 3 by 2. So eventually we can see that this list of numbers is an arithmetic progression. The next terms would be 8 plus 3 by 2, which is equal to 19 by 2. And the next two terms would be 19 by 2 and 11. The next list of numbers we can see is the same number minus 1 by 2, minus 1 by 2, minus 1 by 2 and so on. Here we can clearly see that the common difference D is equal to 0 and the next terms again would be minus 1 by 2 and minus 1 by 2. So this list of numbers is also in arithmetic progression, that is AP. We look at the third list of numbers, root 2, root 8, root 18, root 32. So if we see D, the common difference is equal to root 8 minus root 2, which is equal to 2 root 2 minus root 2, as 8 can be written as 2 root 2 minus root 2, which is equal to root 2. So we can clearly see that this list of numbers is also in arithmetic progression, and the next terms are root 50 and root 72. The next list of numbers is root 3, root 6, root 9, root 12. Here we see root 6 minus root 3 is not equal to root 9 minus root 6. So here we can see that the list of numbers is not an AP, that is not an arithmetic progression. I am assuming that you understand how to subtract roots. We cannot subtract roots directly. The next list of numbers can be 1 square, 3 square, 5 square, 7 square and so on. Here we see 3 square minus 1, which is equal to 8, and 5 square minus 3 square is equal to 25 minus 9, which is equal to 16. Here we can clearly see this list of numbers is not an arithmetic progression. Let's take the last list of numbers, 1 square, 5 square, 7 square, 73 and so on. Here we see 5 square minus 1 is equal to 24, and if we have 7 square minus 5 square, that is also equal to 24. So in this case, we see that this is an arithmetic progression. So next terms are 97 and 121. We have acquired the skill of identifying arithmetic progression, which is the first step. So now, what can really help us is to predict what would be the nth term of an AP, arithmetic progression. So the question is, how to get the nth term of an arithmetic progression? A better question could be, why do we need the nth term of the arithmetic progression? The knowledge of calculation of the nth term can give us a measurable indicator of the value of the nth term directly. That is, we do not have to keep on adding the common difference. This is why we can actually memorize a formula for the nth term of an arithmetic progression. So let's go back to answer the question, how to get the nth term of the arithmetic progression. We have an arithmetic progression, say, with a list of numbers a1, a2, a3 till an and so on, where a1 is equal to a as the first term and the common difference is d. So a2 is equal to a1 plus d, a3 is equal to a2 plus d, which is equal to a1 plus 2d, a3 is equal to a3 plus d, which is equal to a2 plus 3d, and so on. Looking at the pattern, we can say with confidence that the nth term, that is an, is equal to a plus n minus 1 into d. The nth term, that is an of the arithmetic progression with the first term as a and common difference as d, is given by an is equal to a plus n minus 1 in parenthesis multiplied by d. An is also called the general term of arithmetic progression. If there are m terms in an arithmetic progression AP, then AM represents the last term, that is sometimes also denoted with the letter L. Let's take some examples. Find the 11th term of the arithmetic progression 3, 8, 13, 18 and so on. Solution. Here we see that A as the first term is equal to 3. The common difference, that is d, which is equal to 8 minus 3, which is equal to 5. So now we know that the formula an is equal to a plus n minus 1 in parenthesis multiplied by d. We apply the values, we see that a11, that is the 11th term, is equal to 3 plus 11 minus 1 in parenthesis multiplied by 5, which is the common difference, which is equal to 3 plus 50. So here we see finally that the 11th term of the AP given above is 53. Let's take another example. Which term of the AP 3, 8, 13, 18 is 78? Here we know that 78 is in the list of numbers and is part of the arithmetic progression. What we do not know is which term it is. So here we have a, which is equal to 3 as the first term, the common difference d, which is equal to 8 minus 3, which is equal to 5, and then we have 78 as some term which we do not know which term it is. So applying the same formula again, 78 is equal to a plus n minus 1d, which implies that 78 is equal to 3 plus n minus 1 in parenthesis multiplied by 5. Finally, we see that n minus 1 is equal to 15 and n finally is 16. Thus, the number 78 is the 16th term of the arithmetic progression 3, 8, 13, 8 and so on till 78. Let's take another example. How many 3-digit numbers are divisible by 7? So let's look at the solution. The first 3-digit number divisible by 7 is 105, and the last 3-digit number divisible by 7 is 994. Remember the divisibility test of 7 which we discussed in the assumptions? You can utilize that to really check whether a number is divisible by 7 or not. Now with this, we see 105, 112, 119, 126 and so on form an arithmetic progression with the last term as 994. With a is equal to 105 and the common difference d is equal to 7, applying the nth term formula, an is equal to a plus n minus 1 in parenthesis multiplied by d, we get 994, which is the last term, is equal to 105 plus n minus 1 in parenthesis multiplied by the common difference, which is 7. This in turn makes it n minus 1 is equal to 994 minus 105 in parenthesis divided by 7, which is equal to 889 divided by 7. Here we see n minus 1 is equal to 127. So finally n is equal to 128. There are 128 3-digit numbers divisible by 7. This is the point that I was trying to make, that arithmetic progression has multiple applications. One needs to absorb the concept and then the pattern to solve the applications. Let's take a tricky question. My father had put rupees 1000 in a box when I was born. He deposited rupees 500 in the box till the day I turned 18. Today, I'm 18 and allowed to open the box, wondering how much money I would have in the box. So you can pause the video here and solve the question yourself. I would recommend always absorbing the question as to what question is actually stating, and then finally making an attempt to solve it. Hope you were able to see the pattern that makes this as an AP, as an arithmetic progression. If you tried solving the question and got your answer as rupees 9,500, then you're wrong. Let's see why. Solution. On my first birthday, the box already has 1000 rupees that were deposited when I was born plus 500 rupees. So finally, on my first birthday, the amount of money in the box would be 1500. On my second birthday, another 500 would be added. So now it would have 2000 rupees. Similarly, third birthday, 2500 rupees. Fourth birthday, 3000 rupees. Fifth birthday, 3500 rupees, and so on. This forms an arithmetic progression with starting value as A is equal to rupees 1000 and common difference D is equal to rupees 500. So rupees 500 were deposited till the day I turned 18. So 18 times an initial deposit of rupees 1000 was already done. In all, we have 19 terms and not 18 to calculate. So now we want to know what is the 19th term that will give us the amount in the box. Applying the formula for the nth term, that is the 19th term, we have A19 is equal to A plus 19 minus 1 multiplied by D, which in turn we see A is equal to 1000, D is equal to 500. So A box is equal to 1000 plus 19 minus 1 multiplied as a whole by 500. The final answer is rupees 10,000. If you got the question wrong, then you need to be mindful of the traps the question paper setter builds for you. Treat this as a pointer. Logical awareness always prevails, and checking with the final answer helps. The next logical scenario to study is how to calculate the sum of the first n terms of an arithmetic progression. A more relevant question again that comes to mind is why understand the sum of the first n terms of an arithmetic progression? In the previous level, we looked at a problem. The problem was my father had put rupees 1000 in a box when I was born. He deposited rupees 500 in the box till the day I turned 18. Today I am 18 and allowed to open the box, wondering how much money I have in the box. Now let's say the problem is changed differently to say my father had put rupees 1000 in the box when I was born. He started depositing 100 more than the previous year in the box till the day I turned 18. Today I am 18 and allowed to open the box, wondering how much money I have in the box. If we look at the solution, now the question is completely changed. So let's put the values again. Initial deposit is equal to rupees 1000. On the first birthday, the deposit would be 1100. On the second birthday, the deposit would be 1200. Third year, the deposit would be 1300. Fourth year, 1400, and so on. Now, 1000, 1100, 1200, 1300, 1400 forms an arithmetic progression. We can see this very clearly. Applying the nth term logic on the 18th birthday, father will deposit rupees 2800. But I don't have the total money in my box. Ah, now you see the difference. Earlier, the deposited amount was constant, but now the amount deposited was also increasing every year. So the nth term logic cannot be applied to know the total money in the box. This finally settles as to why some of the first n terms of an AP are going to help us. Coming back to the core question now, how to calculate the sum of the first n terms of an arithmetic progression? So S represents the sum. We all know the terms till the nth term in an AP are A plus D, A plus 2D, A plus 3D, and so on. Sum of all the terms is denoted by S. So S is equal to A plus D plus A plus 2D plus A plus n minus 1D, and so on. Rewriting S in the reverse order, S is equal to A plus n minus 1D plus A plus n minus 2D, and so on till we reach A. Adding equations 1 and 2, we get 2s is equal to 2a plus n minus 1d plus 2a plus n minus 1d and so on plus 2a plus n minus 1d n times, which implies that 2s is equal to n multiplied by 2a plus n minus 1d. S is equal to n by 2 into 2a plus n minus 1d. S is equal to n by 2 a plus n minus 1 into d. So S finally is equal to n by 2 multiplied by a plus a raised to the power of n. This is the last term. This is exactly what Carl Gauss did at the age of 9 to get the sum of the first 100 numbers. We have taken a full circle, started with the story and ended with the explanation. It is time we look at some applications also. Let's take an example. Find the sum of the first 21 terms of the AP, that is 18, 14, 10, 6, 2, minus 2 and so on. So as a solution, we see 18, 14, 10, 6, 2, minus 2 is an arithmetic progression. The answer is true. So A is equal to 18 and D is equal to minus 4 and N is equal to 21. So S as a sum of the entire arithmetic progression series is equal to n by 2 multiplied by 2a plus n minus 1d in parenthesis. So S, which is the sum of the AP, is equal to 21 by 2 into 18 plus 21 minus 1 into minus 4. This is equal to 21 by 2 multiplied by 36 minus 80. So we get minus 462. Let's take another example. How many terms of the AP 24, 21, 18 must be taken so that their sum is 78? Solution. Let's label what we have. A is equal to 24, B is equal to minus 3 and the sum is equal to 78. So Sn is equal to n by 2 and in parenthesis 2a plus n minus 1 in brackets multiplied by d. So we insert the values. 78 is equal to n by 2 into in brackets 2 into 24 plus n minus 1 into minus 3. Finally, we get n by 2 into 51 minus 3n, which becomes a quadratic equation, and we divide it by 3. N squared minus 17n plus 52 is the final equation. Splitting the term method for quadratic equations. Treat this as a pointer. Quadratic equation also show a pattern, so this question requires knowledge of two patterns to solve it. This is very basic general trend in all logical subjects. So here we get n minus 4 multiplied by n minus 13 is equal to 0. This is a very basic general trend in all the logical subjects. So finally, solving the quadratic equation, we see n minus 4 into n minus 13 is equal to 0. So either n is equal to 4 or n is equal to 13. Both are correct. So number of terms which add up can be either 4 or 13. Two answers are possible as the arithmetic progression A is positive and D is negative. The sum of the terms 5th to 13th will be equal to 0. It is a very important assumption to understand. Let's take another complex example. The sum of rupees 700 is to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is rupees 20 less than its preceding prize, find the value of each prize. Let's start with the solution. As each prize is 20 less than the preceding prize, this will form an arithmetic progression. There are 7 prizes to be given, so the total number of terms are 7. The sum of all prizes is 700 rupees. Say highest prize given is A, the next prize will be A minus 20, then A minus 40 and so on. So S is equal to 700 here, N is equal to 7 and D is equal to minus 20. Apply the sum of the arithmetic progression formula. We have 700 is equal to 7 by 2 multiplied by 2a plus 7 minus 1 into as a whole minus 20. Here we get 2a minus 120 is equal to 200, which implies that a is equal to 160. The prizes given are rupees 160, rupees 140, rupees 120, rupees 100, rupees 80, rupees 60, and finally rupees 40. These are the 7 prizes that are given. Let's take another example. A spiral is made of successful semicircles with centers alternating at A and B, starting with center at A of radii 0.5 centimeters, 1 centimeter, 1.5 centimeter, 2 centimeter as shown in the figure. What is the length of such a spiral made up to 13 consecutive semicircles? Take pi is equal to 22 by 7. Let's look at the solution. This question looks tough, I will admit that, especially looking at the spiral, but honestly, it is not. The perimeter of a semicircle will give its length, which is equal to 2 pi r divided by 2, which is equal to pi r. Length of the first semicircle is pi into 0.5. Length of the second semicircle is pi into 1. Length of the third semicircle is equal to pi multiplied by 1.5 and so on. Once we add the lengths and take pi as common, the sum of the lengths of the semicircles, which is equal to pi into 0.5 plus 1 plus 1.5 and so on in parentheses. Now is the time for pattern recognition. The terms inside the large bracket is actually in arithmetic progression. So 0.5 plus 1 plus 1.5 and so on is an arithmetic progression. A is equal to 0.5 and D is equal to 0.5. Calculate the length, that is sum of the 13th spiral. 13 divided by 2 into 2 into 0.5 plus 13 minus 1 into 0.5 is equal to 13 into 1 plus 12 into 0.5 divided by 2 is equal to 45.5 centimeters. Now this question is again a question that requires knowledge of two concepts: knowledge of arithmetic progression and knowledge of perimeter of a circle. Don't forget the writing centimeter as it corresponds to centimeters. Remember, units and dimensions give measurability. This brings us to the completion of the course. I've shared how your mind needs to apply the logic once you know you have an arithmetic progression. One needs to weigh in what strategy or a combination of strategies will work for the pattern. Remember, either the nth term will give you the value or the sum of the arithmetic progression will give the value has been explored. This brings us to the conclusion of this course. Hope you liked the presentation. Don't forget to attempt the challenges. Happy learning!